Okay, good afternoon, class. So today we will continue 3.2, determinant. All right, so determinant is very important in matrix. Okay, and what is determinant? All right, the determinant of a square matrices, for square matrix A. So determinant only exists for square matrix, right? So the determinant of a square matrix A is symbolized by DETA, DETA, that A, or we use the modular sign. But it doesn't mean modulus, it just use the symbol like a modulus. All right, so these two are the symbol for determinant. Either you write DETA or you write modulus A. But don't confuse. It doesn't mean modulus means everything go to positive. Or it doesn't mean in algebraic because this is matrix. Okay, or we can write it in this way. This is a 2 by 2 matrix and we don't write the bracket but we replace with the modular sign. Then this is determinant. So this is a determinant for 3 by 3 matrix. All right, so this is how we write a determinant of a matrix. Okay, and what this determinant bring to us, what is show. Okay, so this is a value. So determinant is actually just a number, a value used to determine whether a matrix has inverse or not. Still remember inverse matrix? All right. So this value of determinant will show us whether a matrix has inverse or not. Also remember that not all matrix has inverse. All right. So how we know from it? So A, if matrix A is a singular matrix, or we say non-invertible, if determinant A equals 0, means when we calculate, if this determinant of A is equals to 0, so it means that this matrix has no inverse. All right, it has no inverse. All right, so a matrix with no inverse, we call it singular matrix or non-invertible. All these terms you must memorize. All right, you must memorize it because the question sometimes will just say that A is singular matrix. So you must know what is the meaning of singular matrix. All right, so remember singular matrix or non-invertible means a matrix with no inverse, means the determinant of A should be equals to 0. And B, if matrix A is non-singular matrix, or we call it invertible, then the determinant A will not equals to 0. All right, it can be any number, but not 0. So this one will has inverse. All right, so this is how we use determinant. Okay, then number 3, determinant of the matrix identity. Still remember matrix identity? We can write in this way in the modulus form is equals to 1. And the determinant for null matrix, remember 0 matrix is equals to 0. Because if it is null, it is a null matrix or 0 matrix, it has no inverse. Okay, so next 3.2.1, we will see how we are going to calculate the determinant for a 2 by 2 matrices. For a 2 by 2 matrix. All right, 2 by 2 matrix is easier, which you have learned in SPM. So let's say you are given a matrix A with elements A, B, C, D. The position of A, B, C, D is very important. It must in this order. Means A here, B here, C here, and D here. All right, this must be in A, B, C, D. Must follow this order. Then the determinant of a matrix A of order 2 by 2 will be, we can write in this way or this way, which is AD minus BC. AD minus BC. I hope you still remember. This one you have learned in SPM. Okay, so this is just a 2 by 2 matrix, which is very simple. Okay, so we will look at checkpoint 3.3, which is in page 177. Okay. We just discuss orally lah, very fast. Okay, one you can do it yourself. Okay, it's just AD minus BC. So I will discuss number 2. All right, so you are given matrix A is 4, 1, 2, 1. Matrix B is 3, 2, 1, 2. Okay, you are asking to find determinant of A and determinant of B. Then find product AB. All right, so after that, you're asking to show that the determinant for product AB same as determinant A multiplied determinant B. This is for a 2 by 2 matrices, so it will be easier and simple. Okay, so let's look at the solution. All right, since A is 4, 1, 2, 1, so determinant A will be AD minus BC. So 4 minus 2, which is 2. Okay, whereas determinant for matrix B is AD minus BC. So 6 minus 2, which is 4. All right, then we are going to find the product of AB. Still can see? Okay, so A is 4, 1, 2, 1. B is 3, 2, 1, 2. Still remember? First row, first column. So 4, 3, 12. 12 plus 1. So first row, second column. 8 plus 2. Alright, then second row, first column. 6 plus 1. Okay, then last one, 4 plus 2. Okay, so this is the product. Alright, now we find the determinant for product AB. So same, AD minus BC. AD minus BC. Alright, so this one 6, 3, 18, this one 78, this one 70. So the determinant for this product of AB is 8. Alright, then we see what happened to determinant A multiplied determinant B. Alright, so 2 times 4. 2 times 4. Also 8. From here we can make this conclusion. The determinant of product AB same as determinant A multiplied determinant B. So remember this concept. Alright? Okay. So question 1 you try on your own, yeah? Okay. Okay, next. We are going to see how to find determinant of a 3 by 3 matrices. A 3 by 3 matrix. Alright, so to find the determinant of 3 by 3 matrix, it will be longer step. Not as simple as 2 by 2 matrix. Okay, it will be longer. So see, if matrix A of order 3 by 3 is given like this, let's say A11, A12, A13, A21, and so on, the value of the determinant of A is found by obtaining 2 by 2 determinant from this 3 by 3 determinant. Okay, so what does this mean? Okay, we will use one example. We will use one example to repeat all the steps. So please follow carefully. Okay, these are the steps to find the determinant of a 3 by 3 matrix. Okay, first step is pick a particular element. So you have 9 elements here. You pick any. You can pick any, yeah? Then cross out the row I and the column J that throw the particular element. Alright, so leave 4 elements which form a 2 by 2 determinant. Alright, so this determinant is called the minor of this element Aij. Minor of Aij. And you can denote it by capital Mij. Alright, so this means that, okay, we take this matrix as one example. This is matrix A. So I will choose the first element, A11. Alright, so what you need to do is, if I choose this one, I will cross this row and cross this column. Alright, so you see, left a 2 by 2 determinant. See that? This is the meaning. Left a 2 by 2 determinant. And when you get the 2 by 2 determinant, you will find the determinant by using the method of 2 by 2 determinant, which is AD minus BC. Alright, therefore, the minor of this element 11, this is A11. So the minor of the element A11 will be AD minus BC. AD minus BC. First time I write it out lah, so easier for you to do revision. Okay, in exam or when you do exercise, you can just calculate the answer. So 42 minus 40. So the minor for the first element is 2. This is how we determine the minor of each element. Okay. Then next step. After we have determined the minor, the next step is actually very simple. Alright, so you see, each minor has associated sign, means either positive or negative, depending on the position in the determinant of the element of which they are a minor. Alright, so this associated sign are shown as this diagram. Memorize it. Very simple. It just start from positive, negative, positive. So the second row start from negative, positive, negative. And the third row repeat as first row, positive, negative, positive. Just remember this sign. So the minor of a particular element together with its sign is called the cofactor of the element and is denoted by Cij. Alright, therefore, a cofactor of an element is same as -1 I plus j multiplied with the minor. Okay, this one you don't have to memorize because actually this -1 to the power of I plus j will come up to with this position with the sign. Or you just memorize positive, negative, positive, negative, positive, negative, positive, negative, positive. That's it. Alright, so for, let me check. Okay. Alright, so very simple for this. Just now we already know for element A11, which is 2. Alright, the minor is also 2. So the cofactor for this element 11 will be, so 11 is here. Alright, the sign is positive. So positive multiplied with the minor. So the first and second step is how to determine the minor and the cofactor for each element. Alright? Of course, later we are going to find all the minor and cofactor for each element. Okay. Alright? Then the next step will be, step number 3 will be, we can now write the determinant of A as the sum of the product of the element of any one row or one column with their respective cofactor. This is how we calculate determinant. Alright, so means that you can either use cofactor or minor. Okay, if I use cofactor, then the determinant for matrix A will be A11 multiplied with C11, the element of the first element multiplied with its cofactor plus the second element multiplied with its cofactor plus the third element multiplied with its cofactor. All right, or if you use minor, it's actually same. You see, the element multiplied with its minor. This one is element multiplied with its cofactor. So the only different thing is the sign. See? The only different thing is the sign, because minor we haven't add in the positive negative sign. So this is for first row. This is for first row. So if first row, first element positive, second element negative. So third element positive. So it depends which one you want to use. If you use minor, just remember the sign. All right? So if you use minor, be careful of the sign of the row that you use. All right? So you can choose any row or even any column. So you choose, after you have choose, so you calculate the minor or the cofactor for all the element in that row or in that column. Then you follow this formula. All right? Then you will get the determinant. Okay? So you can try at home. No matter which row or which column you use, the answer, their answers are all the same. All right? So we will see, we will discuss one example. All right? In details. Okay? So question 1 as usual, your homework, checkpoint 3.3, question 3 to 10. Okay, question 2 also you do as homework. All right? Sorry. No. Question 3 is homework. Question 3 homework. I will show you question 2. All right? I will show you question 2. Okay. All right. So question 2. So the question say that find all minors and cofactors of matrix A. Hence, find determinant A. All right. So this question, they want you to find all the minor and factors. Okay. So I show you all. All right. So you see, this is matrix A. Remember the sign. Remember the sign for the minor. Okay, so first we start with first row. Okay, we start with first row. So first element is 3. All right. So the minor M11 will be, so because I'm choosing this element, so I have to cross this row and this column. So left this 4 element, right? So I write in this way lah. Okay, so left this 4. So the determinant, 2 by 2 determinant. So this is a meaning. Obtain a 2 by 2 minimum determinant from the 3 by 3 determinant. All right. So you follow the formula AD minus BC. So 4 minus 0. So 4. All right. The minor is 4. And the cofactor also 4. Because for the first column, the sign is positive. All right. Now second. All right. Second element, negative 1. All right, so M12, I'm going to find the minor for this element. So I'm choosing this element. So again, I have to cross first row and second column. Cross it up. So again, left these 4 elements and become a 2 by 2 determinant. See? 2, negative 3, negative 2, 4. Left this 4. All right, so I copy down here. So again, use the method AD minus BC. So 8 minus 6, 2. All right, the minor is 2. Okay, so how about the cofactor? So remember, this element, A12, the sign is negative. Therefore, the cofactor for element 1, 2 is minor is 2, so cofactor is negative 2. All right. Then the third element also the same lah. This is the third element 0. All right. So I'm going to cross first row and third column. After I have crossed, so you see it left this 4. All right. So left a 2 by 2 determinant And after you calculate, the minor is 2 and the cofactor also 2 because the sign for the third element is positive. Alright, so this is for first row. Alright, so now we are looking at second row. Alright, so second row, I'm going to choose this element. So I'm going to cross this row and this column. This row and this column. So left this 4. Left this 4 element and become a 2 by 2 determinant. Alright, so the minor for element 2, 1 is negative 4. And for element 2, 1, the sign is negative. So the cofactor become positive 4. Negative 4 is positive 4. Is it okay? So follow the same method. Alright, so I can get the minor for M22, C22, M23, C23. Alright, then this is the third row. This is the third row. M31, C31, M32, C32, M33, C33. Alright, follow the same method. You cross the row and the corresponding column and left a 2 by 2 determinant. Alright, okay, now to calculate determinant of matrix A. So to calculate determinant of matrix A, you just need to choose any one row or column. If you choose row, it's like this. If you choose column, then you see like this. Okay, the answer are the same. You can try. Okay, so for me, I will try using the first row. I'm using first row to calculate the determinant. Alright, and first row, the first element is 3. So 3. Alright, multiplied with its, remember I say, either you are using minor or cofactor. So I prefer cofactor because I don't have to worry about the positive negative sign already. Alright, so the cofactor is 4. Alright, second element, first row, second element is negative 1. Okay, multiplied with its cofactor, negative 2. Okay, so first row, third element. Third element is 0. Multiplied with its cofactor, 2. Then you add up. So 12 plus 2 plus 0. So the determinant for matrix A is 14. So this is a non-singular matrix because it has inverse. Alright? Okay, so this is how you find the determinant of a 3 by 3 matrix. Of course, when you do exercise or in exam, if the question just want the determinant, you don't have to calculate all. You just choose any one row or any one column that you want. Then you find the cofactor for all the 3 elements in that row or that column. Then you sub into this formula. Alright? Okay. So I have discussed question 2. Alright, so homework. Question 3 you do as homework. Because it will repeated as 5 lah. Given a determinant of a 3 by 3 matrix, determinant of a 3 by 3 matrix is equals to 0. Find the value of x. So as I said just now, you choose any row or any column to calculate its cofactor. Then you sub into the determinant formula and equals it to 0. Because the question tell you it is 0. Then you will get your x. Alright? Okay, whereas question 4 and 6 will be the quizzes that you need to do after this lesson. Right after this lesson, you have to complete this quiz in about the most 20 minutes. It should be, you should use only 16 minutes actually. Alright, but the most you use up to 20 minutes will do. Then you upload to the Google Drive. I think I will forward you another new Google Drive. Okay, because the previous one, too many questions inside already. I haven't seen it all right. Okay, all right, so now I will go to question 5. All right, questions 5. So you are given matrix A like this, in terms of T, you see. Find the value of T if A is a singular matrix. You see, the question will ask you like this. So you have to understand what is the meaning of singular matrix. So singular matrix means no inverse. No inverse means same as this one. The determinant equals to 0. All right? Okay. So let's look at the solution. So this is the solution. Oh, I'm sorry. Okay, sorry. All right. Okay. So this is question 5. So I given this is matrix A, right? The question say A is singular. Therefore, determinant of matrix A equals to 0. So to find the determinant, I need to choose a row. So I'm going to choose row number 3. Why row number 3? Because I've seen 0, 0. It will be actually easier. Alright, so means that I don't have to calculate the cofactor for these two elements, because later they are going to multiply with 0. Okay, it becomes 0. So then I can skip this. Alright, only left this. Okay, I need to find the cofactor for this element. So for this element, I have to cross this row and this column. So left this 2 by 2 determinant. I write it here. Alright, so this is a cofactor for C33. And remember this? Yeah. For C33, the sign is positive. So positive lah. Alright, positive for this 2 by 2 determinant. Okay, so AD minus BC. So AD minus BC. Okay, now therefore the determinant for A, for matrix A, will be 0 multiplied C31, 0 multiplied C32, which is these two, so that I don't have to calculate this one, because multiplied with 0 all becomes 0. Okay, then element 33 multiplied with its cofactor from here. Okay, and it's supposed equals to 0, because the question says it is singular. Alright, so equals to 0. So left this one. So this one, when I elaborate, t squared plus 1t minus 2t negative t minus 2. So minus 2 minus 4 minus 6. Alright, and this is another quadratic that we can factorize. Alright, so therefore your t can be 4 or 3 or negative 2. Alright, so when t equals to 4, 3 or negative 2, so matrix A will become singular matrix, no inverse. Alright, if t is other numbers, then it will have inverse. Okay. Alright, so 4 and 6 you do as quiz, yeah? Same, you see. Find the values of k such that the determinant of the matrix is 0. 4 marks. Question 6, you see this is STPM 2006. Alright, after 14 years, it came out again last year. You are given matrix M. If M is singular, form a cubic equation. Alright, then calculate the possible values of t. Okay, the method actually same as question 5 that I have discussed. Alright, this is how you form, you see, form a cubic equation. This is cubic what, right? But this question, of course, different now, because just now question 5, I have 0, 0 here, so which is easier. Alright, so for you, you choose any row or any column. Alright, any row or any column. Okay. Then question 7 also, you please do as homework. Alright, you are given matrix AB. show that A is not singular. A, only A, only matrix A. Show that A is not singular means you find the determinant, and the determinant shouldn't be equal to 0. Alright, then you find your product AB, multiply it. Alright, find it, after you multiply, find the determinant. Okay, and you show that the determinant for product AB same as determinant A multiplied determinant B. It's same as the question 2 that I discussed in checkpoint 3.3 just now. Alright, just that this is 3 by 3. So you do it as homework. Alright, okay, we'll go it faster. Okay, the next part is 3.2.3, the properties of determinant. We have learned how to find determinant, right? There are some property about determinant that we can memorize so that it can make our solution easier. Okay, the following are properties of determinant of the third order, but properties are true in general. In general, they are true lah. Okay, number 1. If any two rows or columns are interchanged, then the sign of the determinant is changed. For example, this one. This A1, 2, 3, B1, 2, 3, C1, 2, 3. Compared to this one, you see, row 1 and row 2, they exchange the position only. Alright? Then the sign of the determinant same. So the determinant for this one is same as the determinant for this matrix, just that the sign change. Or if this one positive, this one become negative. Alright, so you can refer to your textbook page 175 for the example to show this property. Okay, so number 2, if two rows or column are identical, the value of the determinant is 0. Identical means, you see, exactly the same. Any two rows or two columns. It's not necessarily 1 and 2. It can be 1 and 3 or 2 and 3. As long as if they are the elements in these two rows, any two rows or any two columns are the same, the determinant definitely equals to 0. Okay? So number 3. 3 are divided into 3 parts. Alright? If the entries of a row or a column of the determinant are multiplied by a constant k, then the value of determinant is also multiplied this k. Like this. See? The original matrix is A1, 2, 3, B1, 2, 3, C1, 2, 3. Let's say, first row multiplied, all the element in first row multiplied by k. So the determinant of this matrix same as the determinant of this matrix but multiplied with k. So don't confuse. This is not multiplied constant to a matrix, you know. So you don't have to multiply it into all. This is determinant. See, this is determinant. Okay, not matrix. If it is matrix, then yes, the k have to. If it is a matrix, then yes, k have to multiply into each element. But this is determinant. Okay, so this rule, this is true for all square matrices of any order. B is if all the element multiplied by k, determinant, this is determinant, all the values in the determinant multiplied by k, then it's same as the determinant of the original matrix, but multiplied with k cube. See or not? If one row only, 1k. So if two row, 2k squared. So if all three rows, k cube. Alright? And even though like row A multiplied with k, but row B multiplied with h, row C multiplied with L. Okay? So it can be written in k multiplied h multiplied L. And multiplied with the determinant of the original matrix. Alright? But this B and C only true for 3 by 3 matrices. Okay, all this in your textbook actually. If you want to see the example, you can go to page 175. Okay, next. Okay, all right. So next, number 4. If every entry in a row is 0, then the value of determinant also 0. Or any row or any column. If all the elements are 0, determinant are 0. Number 5, transpose. Still remember transpose? Matrix A and transpose A. Transpose means the column here, the row here become the column. then their their determinant are the same. All right, their determinant are the same. Number 6, if any true row of the determinant is added to or subtracted from another row, then the value of the determinant remain unchanged. Or this one just means that, for example, this is a matrix. I add this one, become a new row. All right, so this matrix will have the same determinant with the original. All right, okay, number 7, if the entries of a row of the determinant are expressed as a sum of 2 or more terms, then the determinant can be expressed as a sum of 2 or more determinants. Oh, just like this. Then we can split it. Okay, number 8, the determinant of a diagonal matrix. Still remember diagonal matrix or a triangular matrix? All right. So this is triangular matrix. This is lower. Still remember lower triangle. Diagonal matrix. Up is all 0. So this is lower triangular matrix. All right. Not only triangular, diagonal also can. All right. So the determinant will be the product of the entries on the major diagonal. Very simple. The determinant is you just multiply the 3 element in the diagonal, the major diagonal. All right. Okay, number 9, this one we have discussed. All right, determinant of product AB, same as determinant A multiplied determinant B. Okay, number 10. Number 10, the determinant of inverse A. All right, the determinant of inverse A, same as the inverse of determinant A. This is the symbol for inverse. Okay, this is the symbol for inverse. This one doesn't mean this. Okay, be very careful. This is not algebra. This is matrix. All right. So this is a symbol for inverse matrix. It doesn't mean 1 over A. But this is inverse. So the determinant of inverse A, same as the inverse of determinant A, which is 1 over determinant A. All right, because determinant, remember, determinant is a number. So number can be 1 over. All right. So how we prove this? Very simple. We know this concept, right? Any matrix multiplied with its inverse, you get identity. All right. So if this matrix and this matrix are the same, then definitely the determinant are the same. And we have this concept, right? We have proved this concept, so this one also can split. Okay, because this is determinant, so I can shift it here. I shift it to this side, become like this. All right, and 1 over determinant A means determinant A to the power of -1. So this is actually to the power of -1. This one, this is to the power of -1, but this is not. This is the symbol. All right. So you have these 10 properties of determinant of a 3x3 matrices. Okay. So look at example 3, 2, 3. Example 3, 2, 3. Okay. Use the property of the determinant to find the value of x. So you see, all the determinant given to you is equals to 0. All right. Only 2 properties that tell you the determinant is equals to 0, which is property 2 and 4. All right. So you use 2 and 4 to solve this one. You read. Okay. You see what is 2 and 4, then you solve this one. All right. Question 2, no need. Forget about it. Because I also don't know what I want. I can't remember what to do. So just forget about it. All right. So I will discuss question 3. Okay. And I want you to do question 4 as quiz. So means after this lesson, you must complete all the 3 questions. In front just now 2 plus this one. All right. So this one you just complete A, B only. All right. To find inverse A, we haven't go into this one yet. No need. Okay. So you do STPM 2017 method M. You are given matrix A. Find the determinant of A. All right. Hence, obtain the determinant of inverse A. So you use this property lah. Okay. So we are now we will go through question 3. Okay, so question 3 is STPM 2015 in Mathematics here. Can see? Okay, can. Alright, so you are given matrix M and matrix N. This is M, this is N. Alright, show that the determinant for M is this one. So answer given to you, you just show 4 marks. Then from M, you deduce determinant of M. You see? So means you have to use the property that we have discussed just now. That's 2 marks only. Okay? Alright, we start with matrix M. Alright, so again, I'm choosing the first row. You can choose any row, any column, you can choose. Okay, I'm choosing the first row. So the cofactor for C11, so this one, so cross here and here, left this determinant, AB minus CD, AB minus CD. So I simplify it. Okay, then cofactor for second element. So second element, the sign is negative. Remember this. So cross here and here, left this 4. So negative AD minus BC. So I simplify, I get this. Alright, and C13 lah. Is this one. Okay, so determinant of matrix A is, for first element is 1. So 1 multiplied with each cofactor. This one. Second element is A. So A multiplied with each cofactor. So this one. Alright, third element is BC. So BC multiplied with each cofactor. This one. Okay, so we just need to think how to rearrange until we get this thing. You see this is in the form A minus B, B minus C, and then C minus A. Okay, so this one will remain. This one A square. This one, I factorize out the negative. I factorize out the negative so that it becomes B minus C. Alright, why I want this? Because I see B minus C here. So that I can factorize out B minus C. This is why I change this one. Alright, so I factorize out B minus C. So left A, B plus C. So this one left negative A square. This one left BC. Alright, so I elaborate this one. Elaborate. And we see we have C and C here. Alright, and we have A and here. So we factorize out. This one. AC minus BC. We factorize out C. Okay, another one is A, B, and A square. I factorize out A. I factorize out minus A. So minus A square plus AB. Okay, so I get A minus B, A minus B. I factorize out A minus B, left C minus A. See? Just rearrange. Rearrange this, follow what the question want. Okay, so this is how we calculate and show the determinant of M. Alright, okay, let's look at next one. How to deduce matrix N. Alright, so this is matrix. Can you see? Okay, so this is matrix N. Alright, and this is the determinant. Alright, so you look at the third row. All with 3. This determinant, so I can factorize out the 3. Only determinant can do this step. Alright, you don't do this step to the matrix, cannot. Okay, so you see that when I take out the 3, this is actually matrix M. See that? This is actually matrix M. It's determinant for M. So we are using the property number 3A. You can refer back. Alright, property number 3A. So determinant A is actually 3 times of determinant M. So just write it out only. So 2 marks here. Okay? So it seems like to ask about the determinant of the property of the determinant. Oh, so you see, so far never ask, never ask. Suddenly they ask in 2015. So anything that look like not too important, you also must be bear in mind. All right? Okay, so today we will stop here. So please complete all the 3 questions and upload it into the Google Drive. And please, when you watch the video in YouTube, don't forget in the comment part, type your name. All right? Because for the first lesson of matrices, I think I only saw 6 names, 6 or 8 names only. So how about others? Have you done? Oh, please remember, that you have to type your name in the comment so that I know that you have watched the video. Okay, so we stop here today. So enjoy your lesson. Thank you. Bye.